Hello to you all, Mindsetters, Grade 12 Mindsetters. This is the day that we've all been waiting for. It is the start of our spring school. Welcome, and I hope you're all up and ready, because on the Facebook page, it's been buzzing with people saying, we can't wait for the show. Well, this is the live show, especially for you. My name is Abraham, and I'm not alone. I'm joined by Lee. How are you, Lee?
Nice to be with you, Abraham.
Thank you so much. Are you feeling good this morning?
I'm feeling excellent, and I was just thinking how lucky the matrics are that the weather's cool, because
Yes.
it's always better to learn when it's
Yes,
cooler.
and they can sit, have their coffee, and learn more with
That's
us.
it.
Nice one.
Perfect.
What are we doing today?
We're doing calculus, and in particular functions of calculus. So we'll be concentrating on drawing the graphs and a little bit of functions beyond the calculus as well.
All right, now Mindsetters, tell all your friends to join in and tune in and learn more with us. Have your calculator, your pen, and log on to Facebook. Our Facebook page is facebook.com/learnextra. Like the page and join other Mindsetters. We have about 53,000 already Mindsetters on the page. Otherwise, we also have a math study group, which is called Mindset Maths. Join that study group and help one another, because we're here to assist you. Otherwise, you can tweet us, follow us on LearnExtra, at LearnExtra rather. And lastly, you can download your notes all for free on the link that I'm going to be posting, which is on learnextra.co.za/spring school. I'll post the link and make sure that you also get your notes on the Facebook page. But otherwise, let's learn more.
Great, let's get going. As I say, we're doing functions and calculus. So let's move into the first question. Right, the first question, as you can see, was taken from February-March 2013, paper 1. It was question 10. It says, given that f of x equals minus x cubed minus x squared plus x plus 10, then there are a whole lot of questions coming. But the moment you see that, I think you know what's going to come. It's a cubic graph. In all likelihood, if the graph is not drawn, you are going to draw it. And what's important to know is that to draw a cubic graph, there's some things you need to do. You have to find the x-intercepts, you have to find the y-intercept, you need to worry about the shape, you need to worry about the turning points, and you need to worry about the point of inflection. But usually they're not so cruel as to say just sketch, they help you out, and this is what this question's done. So let's look at the first one. The first one says to me, given the equation, write down the coordinates of the y-intercept of f. Right, so let's go and do that. So if we hear the word y-intercept, it does help if one gets the pen to work. We know that we're going to let x equal 0. Right, now if x is 0, it's very easy, because remember, f of x is the same as saying y equals. So we know that y equals, and if x is 0, this would be 0, this would be 0, this would be 0. So all we're going to get is 10. And so we have a coordinate 0, 10. You'll notice they asked for the coordinates of the y-intercept, so I make sure I answer the question. If I don't provide the coordinate, I haven't actually answered the question. And so I think it was worth 1 mark. You could end up with half a mark or no marks if you don't answer. Usually they're kind in the matric final, and they try to help you out as much as possible. Okay, let's go to the next question. The next question says, show that 2, 0 is the only x-intercept of f. So as soon as we see the word x-intercept, we let y equals 0. So we have 0 equals minus x cubed minus x squared plus x plus 10. Now they've helped me out a bit. They've said show that 2, 0 is the only. So they've already told you one of the roots, which is very good news. Now what I would do immediately is I would change the signs, because to work with a minus x cubed is not as nice as working with a plus x cubed. So because there's a 0 there, whoops, it's just happily moved on its merry way. Let me just bring it down. Decided, oh, well, you know what, I'm just going to leave it there. It's fine. Because that's the case, I can make it 0 equals x cubed plus x squared minus x minus 10. Now, if 2, 0 is one of the solutions, that means there must have been a bracket that read x minus 2. So this is going to be x minus 2, and what we need to do is find the rest of that. Now, what I want to say to you at this stage is there are many ways to find the rest of that. The one way is to use long division, and I know that that's never anybody's favorite choice, but the other way is by inspection, and that is the one I would suggest you use. It's quick, it's easy, and simple. So let's show you how that works. Right, so what we would do is we'd look and we'd say, in order to get an x cubed, let me just change the color of the pen, I need to have an x squared here. Let's just check it out. There's that times that would give me x cubed, all is good. Then, in order to get a minus 10, I've got a minus 2, I must have had a plus 5 over there. Check it out. Yes, that gives me minus 10. Now, what some people teach you to do, and I think it's a good idea, is you write here, this must be a kx. Now, if that's a kx, we know that we're going to look at this and we're going to times that by that and get kx squared. And then we're going to times that by that and we're going to get minus 2x squared. And what do we know? It must equal in this expression plus x squared. Do you agree with me? That's what the x squared term is. Now, I needn't have used x squared. I could have used x instead of x squared. I will do it the long division way as well, just so you can see it. So this becomes kx squared equals 3x squared. And so that means that k equals 3. If x squareds are the same, the k must equal the 3. So what do we know now? We know that this equation is 0 equals x minus 2, and this is going to be x squared plus 3x plus 5. All right, so let's just keep it blind there, and let's just take it up a bit, and I'll show you the long division way, in case that's what you prefer. The long division way is you would put your expression in here, which was x cubed. I must just remember it, so I'm going to refer back to it. It was x cubed plus x squared minus x minus 10. Plus x squared minus x minus 10, I think. And we were dividing by x minus 2. Now, I'm sure you remember the little rhyme that you learned for this. You would take this x into this x, and you would get x squared. Now, you would multiply that onto each one of those. So it'll give you x cubed minus 2x squared. Now, the next thing you do is you'd subtract, and if you subtract, you would change these signs. That would become a minus, that would become a plus, so that would fall away. This would become 3x squared, and you would bring down. I'm sure you've heard teachers talk about daddy, mommy, sister, brother. And that's just an acronym for saying divide, multiply, subtract, bring down. Right, now we're looking at the next one, which is to divide the x into this, and if we do that, we're going to get plus 3x. So we're going to times it now onto each of these. So we're going to get our 3x squared minus 6x, and we're going to subtract. Remember, what we do is we change the signs and we add. So we get 5x minus 10. Right, so now we're nearly done. We're going to take our x into that, which is going to give me plus 5. Just go up a little bit. Try and squeeze it in so you can see everything. So it's plus 5. And then we're going to times it onto that, so it'll give me 5x minus 10. And if we change the signs and subtract, they both fall away. And there's our expression, which is precisely what we would have got if we used the inspection way. And you can see it's a little bit simpler, the inspection way. Right, so that means that x must equal 2, or x squared plus 3x plus 5 must equal 0. Now, can we see to factorize that? Well, we know that 5's factors are 5 and 1. And 5 and 1 won't give me 3. So the only way to be sure is to use our formula, or to just use the inside of the square root sign on the formula, but I'll use the full formula. So it's x equals the minus b plus minus the square root of b squared minus 4ac all over 2a. Now, the moment I do that, I've got minus 3 plus minus the square root of 3 squared, which is 9, 4 times a, which is 1, and c, which is 5, all over 2 times a, which is just 2, which is then going to give me minus 3 plus minus the square root of 9 minus 20 over 2, which gives me minus 3 plus minus the square root of negative 11. Now, what do you know about the square root of negative 11? Hopefully you know that that's a non-real number. You can't square root a negative number in our real number system, which is what we're working in. If you were working with non-real or imaginary numbers, you would be able to go further, but that's not in our syllabus, and so there are no real solutions. So we can now safely go back to the question and say, have we shown that this is the only x-intercept? Yes, it's the only real x-intercept. That's quite right. Okay, let's go to the next question. Right, this one says, calculate the coordinates of the turning points of F. Now, turning points, they could also use the word stationary points. So stationary points, turning points, within our context, the same thing. Usually a stationary point implies there need not be symmetry. Turning point usually implies there will be symmetry. There isn't with a cubic, so I think I would have used the word stationary, but it's the same thing for our purposes. So what we would do for a stationary point or a turning point, we would find out where the derivative equals 0. Notice how the words prompt me as to what mathematics. So as soon as I realize what it is, I put it on the side. So if I get into a mess later, I can always go back and look at that. So right, let's have a look at our derivative. So f dashed of x will be minus 3x squared minus 2x plus 1. And for a stationary point, and I must be honest, I would actually tell them this, because you know what, the more kind you are to your marker, the better. So I would go, for stationary point, our derivative must equal 0. Just is nice for your examiner to see what you're doing here. So 0 is equal to minus 3x squared minus 2x plus 1. And if we now change the signs, we're going to get 3x squared plus 2x minus 1. And hopefully that will factorize, and it does. 3's factors are 3 and 1. 1 and 1. This tells me signs different. This tells me bigger set positive. So it's a positive to get that and a negative to get that. So x is equal to 1/3, or x is equal to minus 1. Right, are we finished? No, it said calculate the coordinates of the turning point. So we've got to have an x and a y. Now this is where the calculator will come in quite handy, but I'm not going to use the calculator today. Maybe I still will, but let's say at this stage I won't. But I'm going to use it now to show you. So what I'm going to do is I'm going to take these x values and put them back into the original equation. I can't put it into anything else. It must be this original. So if I'm going to go for the f of, what was the first one, a third. Okay, what I would do is I'd say a third cubed, which is 1/27th, minus a third squared, which is 1/9th, plus a third plus 10. And if I look at that, that's quite nice. 27, 9, and 3 are all divisible into 27. So I can now go back and say, okay, fine. I hope I remember that. I think I do. It's minus 1/27th minus 1/9. So minus 1/27th minus 1/9 plus 1/3 plus 10, if I remember rightly. I'll just check it to make sure I'm not going to make a mistake, because we don't want to make a mistake. It's easy to do if you're not looking at the question, yeah. Okay, so now all I would do is I'd say that's minus 1/27th. I'm going to convert this to 27ths. And if I do, it's going to be 3/27ths. And over here, I'm going to convert this to also 27ths. So I must times by 9 plus 10. Now that's easy enough, because over here I can see minus 1 minus 4, minus 3 is minus 4. Minus 4 plus 9 is 5/27ths plus 10. And that was an easy bit of arithmetic, not too bad. So we have the coordinate 1/3 with 10 and 5/27ths. Okay, but that's only the one. We've still got one more to go. Let's change the color pen and go back to the equation, which was y equals minus x cubed minus x squared plus x plus 10. And we're now going to put in minus 1. And if we do, y is equal to minus 1 cubed is minus 1 times the negative is going to be a plus 1. This is going to be a minus 1. That's a minus 1, and that's a plus 10. And if I add that up, I'm going to get 9. And so my coordinate is minus 1, 9. Now, I'm pretty sure the next question is probably going to be to draw it. So let's go and draw it. Okay, the next question says, sketch the graph. Oh, gosh, sorry, I don't know how I got that there. Let me just put it down. Let me just put it down. Yeah, there you go. Don't know how I managed to press the button that got me that. And we're ready to sketch it. Now, first of all, it is a negative graph. If it's negative, it will go, let's get back to this, it will go down and like this. If it was a positive, it would go up first. I call them slinky and kinky. This one's kinky, it goes down. So now we know that our intercept is going to be at 10, so let's put that in. We know that there was only one intercept, and I think it was at 2, I think. But anyhow, let's do the coordinates first. It was -1 with 9, I think it was. Let me just go back rather than guess. Let me just get those values. It was -1 and 9. So -1 with 9. There's 9 over here, more or less. And then it was a third with 10 and 5 27ths, which is about here. So a third and 10 and 5 27ths. Okay, and this one was -1 with 9. Now, what did I tell you? I told you this is going to go down first. And I know this is my first turning point, so it's going to do this. Must go through the intercept to this one. And then it must go down again, and I just drew a little bit skew, so let's just make that point a bit fatter. Or take that off is even better. Oh dear, let's get the rubber. Yeah, let's put it on again. Sorry, I seem to be having some trouble aligning my pens at the moment. Okay, anyhow, that's fine, and we know that this coordinate was 2. So that would be my sketch. Remember, you must label your axes X, Y, and origin. Okay, in fact, it's better to put the origin there. Okay, so that's how we get our graphs. Nothing too hectic about it. Quite fun doing the question. Okay, so hopefully you're all feeling good about that, and you've got the idea. Okay, so that's that question. Quite straightforward. One other thing they could have asked you is the point of inflection, but there's a question later on that. So we'll get to that later. Avram, I think it's time for a break.
Yes, it is, Lee. And we have some questions on the Facebook page, which we'll take after the break.
Good. Super.
Otherwise, mindsetters, don't move. Get your notes in the meantime on learnextra.co.za/revision. We'll see you after the break. Hello and welcome back, Mindsetters. Now we have exciting news for you. We have a competition which is just for you to win something exciting. It's a prize that you will never ever regret and never ever forget. That's how it is, Lee.
That's great.
It's springtime, so who knows? It's just a surprise prize.
I always like winning anything.
You like winning anything?
Anything. It's
well,
great.
I don't think I have a bad like. I just don't like competitions, because I know that I'm going to win anyway. So here's the competition. What you need to do is check out our Facebook page, the likes that we currently have now. We're going to post a post on Facebook, and that picture has numbers from 0 to 9. All you need to do is to tag yourself on that picture and the number that you like. And now what's going to happen is when we stop the clock at just before the end of this show, before 12:30, the number that is the last number on the number of likes that we have, it's going to be the winning number. And whoever has that lucky number, they'll get you a draw. For example, Lee, currently we have about 53,707 likes.
Okay, so
and let's say,
7.
yeah, 53,707. Now, if your lucky number is 8, it means if one person likes now and we stop the clock, it's going to stop on 708, meaning the last number is 8, and you get to go to a draw. So all you need to do is to take yourself and then give us your lucky number.
And you've got to watch it, because maybe if you just like
it's going to keep on changing.
Like it, it's good.
Exactly, it's going to keep on changing, but you need to tag yourself on that post and then share it. But otherwise, we have some questions.
I'm glad to hear it. What is our first one?
Right. The first question that we have is from Tulufelo Rakomane. It says, is it fine if I use synthetic division to find the quadratic equation?
Absolutely perfect. If you've been taught synthetic division, it's an absolute pleasure. Now, there are two forms of synthetic division. The one is in a kind of division sign, and the other one's like in a noughts and crosses box. Either one is absolutely fine. So yes, it would be a very efficient way of getting it.
All right, and here's a funny one. It's not funny, it's just the name, comedian. It's from comedian Moremi. It says, what are distinct real roots?
Great. Well, I like that name. I love comedy, so I hope you've got a good sense of humor. Right, now distinct real roots. There are many ways of looking at. The one way is to look at the number systems, but I don't think that's what they're asking you. If they say two distinct roots, then they're saying that there are two different answers. So it's not like equal. Let me just show you on the screen what I'm talking about. So if I had a parabola, and it was drawn so it touched the x-axis, say, at 2. That would not be two distinct answers, because there would be two answers, but they would be the same one, because the answer would be x equals 2, x equals 2. In other words, in all likelihood, this equation would have had this kind of format, with some number in front, something like that happening. And so that would be one distinct root. Two distinct roots implies that if let's just take it down a little bit. If I drew this graph with the two distinct roots, it would have something like this going with a -1 and a 4. So in other words, if we were establishing its equation, it would be x plus 1, x minus 4. So that would be two distinct roots, different as in distinct. So if that helps you, hopefully that makes it clear. Is that all our questions so far?
That's all that we have now.
Okay, I'm sure there'll be more soon.
Exactly.
So we look forward to them. Please send them in. It's your opportunity to get some answers.
Yes.
Great. Let's look at the next question I've got for you. This one here we have adapted ever so slightly, because they asked a whole lot of questions earlier on this question, but the last two questions are very, very useful. Now, something I must say is calculus, the graphs in calculus are just an extension of graphs in general. In other words, all your parabolas, and they could have been drawn using calculus, but it's easier to draw them other ways, so we keep to that. But in actual fact, you could do it. So this one says the graph of f of x equals minus 2x squared plus 4x plus 16 has a turning point s, coordinate 118. And the intersection of g of x is at minus 1, 10. Now, that was part of the earlier questions, but we decided it wasn't really worth going through that, because all you would have to do is solve simultaneously for those two equations, and you guys are matrics, you know how to do that. Let's rather show you something that could be more difficult. So, in actual fact, we've given you that coordinate. We've given you this coordinate is easy enough to get if we need it, that t. It's the the x-intercept, and the x-intercept here you could get easy enough by just going, sorry, my pen's going strange. So we're going to go 0 is equal to, and I'm going to change the signs, 2x squared minus 4x minus 16. And I'm going to take it through by 2, so it's x squared minus 2x minus 8. And then that will factorize very nicely to x minus 4, x plus 2. And there's an example for comedian that in actual fact there's two distinct roots here. So there's at 4 and at negative 2. So we know this one's going to be 4, 0. And this one is minus 2, 0. Okay, so that's all the information we need for the question. And the question says, use your graph to solve for x where f of x is greater than or equal to g of x. Now, what that means in terms of graphs is that the f graph must be above the g graph or equal to the g graph. Now, above in terms of a graph means higher on the y-axis than the other graph. So if we go back to our drawing, and let's take a color and highlight it, where is f, which is the parabola, above g, which is the straight line? And we can see it here very clearly. So how would we describe that? Well, if we look here, the x values start at minus 1 and end at 4. So let's go back to the question. It says solve for x. So x would be an element of minus 1 to 4. But because of the equal sign, we would include that point and include that point. Of course, there's nothing wrong with using this notation, whichever one you prefer. Just remember that the top notation, the interval notation, can only be used when we're using real numbers. So if it was like natural numbers, you couldn't use it. But in this case, it's a graph, and we're working in the real number system, so it's absolutely fine. Okay, so that's the first question. Let's look at the next question. And this next question up at, oh, I think I've gone a little bit too far, have I? Yes, I have. One back. This next question I think is particularly nice. It says the graph of the same graphs, there's my picture, but this time they're asking me something a bit different. They say use your graph. Now, if they say use your graph, can you do it another way? No. Otherwise, why are they saying use your graph? Okay, so if it says use your graph, please do that. To solve for x where that happens. But if you look at that, that's not the graph you drew. The graph you drew was y equals minus 2x squared, or rather they drew, plus 4x, and I'm not sure if I think it was 16, but let's just go and check. Yes, plus 16. Okay, so here's our problem. We've got a plus 16 there and a minus 2 there. If we're going to use our graph, we have to have the same equation as the graph we drew. So how are we going to change a minus 2 to a plus 16? Well, the way I see it, let's put this one in blue, and then we'll change the color again to show you what we do to change it. So it's plus 4x minus 2. Now, in order to get it to be plus 16, I would have to add 18. But if I add 18 on one side of the inequality, I have to add 18 on the other side as well. Otherwise, it's not going to look the same. Now, once I'm here, this is good news, because now if I tidy this up, I've got minus 2x squared plus 4x plus 16 smaller than 18. And now I have my graph. So at this stage, I can say f of x smaller than 18. Now I have to use the graph, because that was the question, use the graph. So that means I had to get the equation of the graph in order that I could go to the axis and read off the solution. So let's have a look at it. Okay, so now they want to know, when is this graph, ooh, I'm not drawing too well there, less than 18? Well, it's less than 18 except at 1. Because at 1 it is exactly 18. And they asked me only less than 18. So now I've got to try and express that. So it's always except for 1. Now there's several ways we can write this. The one way is to say x is an element of reals. Subtract the value 1. Or we could go x an element of minus infinity to 1, round bracket because we're not including it, or round bracket 1 to plus infinity, or we could just go x is smaller than 1 or x is greater than 1. So any of these are suitable, and probably you could find another 4 ways of doing it as well. So I'm just giving you some, and if you've got any other ideas you'd like me to check, send it to us on Facebook and I'll tell you whether they are fine or not. Good, so that brings us to the end of that. So let's start the next question, because I think we could maybe finish the next question before we take another break.
Before you move, Lee, actually, I have
got a question.
Yes,
Good.
2 of them. The first one is from Liso Lama.
Yes.
It says, what happens when there's discontinuity?
Okay, discontinuity means that you have to lift your pen to draw it. So, for example, a hyperbola is an example of a discontinuity. So if you've got a cubic, you shouldn't have discontinuity unless they've excluded some of the domain. In fact, most of the graphs we deal with at school level are continuous graphs. A straight line is continuous, a parabola is continuous, a cubic is continuous, and it's starting to look a little bit like a colouring in book, but a hyperbola is not continuous because I have to draw the one bit, lift my pen and draw the other bit. So discontinuities are really not often in our syllabus. If you're doing alpha maths, which I think is what is offered, then you would probably come across it in that. But in our syllabus, discontinuity, the only graph I can, and the other one would be the tan function. The tan function's pointing case of where you would lift your pen to draw it. You know how a tan function looks. It looks like this. And then we have an asymptote at 90, and then we draw another one, and then we have an asymptote at 270, etc. Those are discontinuous. Okay, and of course, if you're really into discontinuity, you would learn that there's a jump discontinuity and removable discontinuity, but it's not in our syllabus. So don't worry about that, but it's nice that you're questioning it. It shows that your teacher's done a very good job, or you've done a very good job, of finding out the difference in our graphs, because we deal with it, but very slightly. But yes, basically most of our graphs are continuous. Any other nice questions?
Nice one, Solana. Here's one from Ru.
Great.
Ru says, are we required to know how to prove the quadratic formula, sum of arithmetic and sum of geometric sequence formula?
Now, in the government, you are requested to do a certain amount of theory. It's a very small percent, I think it's 5% or something theory, and yes, you do have to know how to do it. But I suggest that I think completing the squares considered very much an easy thing, because that's how you get the quadratic formulas. You complete the square to get it. So that would be very easy theory, because you just follow your rules of completing the square. So I think that's very possible. And of course, the sum of an arithmetic and the sum of a geometric are also quite nice. In fact, the sum of an arithmetic comes from a mathematician boy who was very naughty in class, and the teacher said to him, go away and add up all the numbers to 100. And he went away and he did it in 5 seconds, and he came up with a formula. It was Gauss, if I remember rightly. Very interesting. Go and look on the internet about him. He was quite a genius, and the poor teacher didn't know what to do with him.
Wow.
Any other questions?
Yes, here's one.
Good,
the last one
great.
from Kabelo. DJKB Mpatlele. Abraham, here's my question. How do I calculate values of K, translations of cubic functions, when I'm asked real values of K?
All right, so let me just try and understand that question, because that sounds a little bit complicated. So how do I determine values of K for translation? So you meaning like, if I've got a graph and I've got a K value and I say, it must have, I think I know what you mean. Let me see if it's this. If it is, you can let me know, and if not, I will try and tackle it later on. I think what you're referring to is this kind of thing, where we've got a graph, we've drawn of some sort. Maybe let's put the one that we had earlier on, that one that looked like this. And then what they will do is they'll say, okay, the equation is y equals, and they would keep it the same, so say minus x cubed minus x squared plus x plus 10 plus k. What would k be if there's only going to be one turning point on the axis, or something like that? I think that's what he means. So what I would have to do is determine how much I have to shift this graph, so that there's only one turning point, one of the turning points on the axis. So what I would do is I would select the graph, and let's see if it'll let me do that. Hopefully it will. I'm going to see, hopefully, or maybe, let's see what happens. Now, yes, it does. Oh, yay, I'm winning. No, spoke too soon. Let's try again. Select it. Select it. No, it's not letting me do it. Anyhow, I'll just do it in another color then, not serious. What we want to do is we want to say, what would happen if I moved this graph in such a way that it does this? Or, alternatively, if I moved it so that this happened. So in other words, this one is there, and this one is over there. That's what the question's asking. So you've got to now figure out what's happening. So you would know this coordinate. And I think if I remember rightly, it was 10 and 5/27, if I remember rightly, along that line. And I think it was a third. My memory is maybe not so bad after all. And so what we would do now is we say, okay, we want to move it down so that that green happens there. Now to do that, I have to shift this down -10 and 5/27. So I would have to make the k in this case -10 and 5/27. So in other words, this bit here would become 5/27 over here. And then in the case of that, that would happen. If I'm looking at this blue one, and I think the coordinates for this were -19, if I remember rightly. Let's just change to another color. Now I would want it to move from where it is to there, so it's got to move down 9 units. So I must subtract 9, so in this case the k would be -9. So the equation would now read y equals -x cubed minus x squared plus x plus 1. And that would make sure my graph looked like the blue one. And I think that's what you meant by translations. If it's not right, let us know and I will try again.
Right. Please let us know, KP. Otherwise, I think it's time for
a break. Yes, and then we'll go to the next question after that.
Time really, really flies. But let me explain this competition quickly again, Mindsetters. You either tag yourself on that post on the number of good squares there from 0 to 9. You tag yourself on the number, not anywhere else, right on the number. If your number is 0, you tag yourself on 0, or share the post after showing the post, you comment on that and say, my lucky number is 8, for instance, because currently we have 719, meaning if your number is 9, when the clock stops, you'll get to the draw. But otherwise, we haven't stopped the clock. So continue taking yourself and sharing. See you after the break. Welcome back, Mindsetters. Now we're still learning more and learning extra right here on 319. Get your notes right now, because the first link is on Facebook. Like the page, join other Mindsetters, and let's interact. If you have any questions, feel free to post them, and also follow us on Twitter at LearnExtra. Lee, back to you.
Grace, okay, super, let's get going. The next question we've got, I think, is one of the most important questions, because for me, this tells me if you've understood what calculus is all about. So let's look at it, and I'm probably going to discuss a little bit more about it. So let's look at what the question says. It says the graph of y equals g dashed x. In other words, this parabola that they're listing here is the derivative. And h of x, which is a normal graph, are sketched below. The graph of y equals g dashed x is the derivative graph of a cubic function. Now that makes perfect sense, because we know that once we take a derivative of something, we lower its power by 1. So if the original was a cubic and we take its derivative, it will be a quadratic. If the original was a quadratic and we take its derivative, it's a linear. And if we take a linear and we find its derivative, it is a constant function. So we know that that makes perfect sense. Let's read on. It says the graph of h and of g dashed have a common y-intercept at E. Now that's quite important to remember, because why would they tell me otherwise? So let's stress that. C is the coordinate minus 2, 0, and D is the coordinate 6, 0, are the x-intercepts of the graph of g dashed. A is the x-intercept of h, and B is the turning point of g dashed. AB is parallel to the y-axis. So by now you're feeling a little bit worse for wear. What is important is to remember that that is parallel, so it's at right angles. And they have told me those two coordinates, and they've told me they share a y-intercept. Okay, so if they share a y-intercept, to find that y-intercept will be no problem, because I do have the equation of the straight line, which I'm just digging out here. I think it's, y equals 2x minus 4. So I'm just going to write it on here. Y equals 2x minus 4. So that means we would find the y-intercept of that graph. So we would let x equals 0. So y is equal to 2 times 0 minus 4, which means y is equal to minus 4. So we know E's coordinate is 0 for x minus 4 for y. So we've got this coordinate, and this coordinate. Right, let's read on. I think it might be on the next page, so I'll just go to the next page. Yes, it says write down the coordinate to E, so I've sort of preempted the story. Remember, the coordinate of E was 0, negative 4, which I worked out in the previous one. Remember, again, if it says the coordinate, make sure you write the coordinate. Okay, the next question says find the equation of the graph of g dashed in the form y equals ax squared. Oops, I can see they got a little drunk square over there. It's had a heavy night at the party. It's ax squared, and that one should not be there. Plus bx plus c, that's the format of a general parabola. So what do we know? We know that the graph looked like this. We knew the y-intercept of 0, negative 4. And then I think we knew that this was negative 2, 0, and this one was 6, 0. I'll just check it before we start working. So I don't want to do all the way down and then discover we've made a mistake. So let's just go back up there. 3.1, 3.2, let's just check and make sure I haven't forgotten my, minus 2, perfect. Right, so let's have a look how we do it. Now, if we know the x-intercepts and the y-intercept of a parabola, and we have to find its equation, it's not hard to do. We are going to use the equation y equals a, x minus x1, x minus x2, where x1 and x2 are the intercepts. So we have y equals a, x minus minus 2, so it'll come plus 2, and x minus 6, so it'll stay just as it is. Now, we're still missing our a value. To get our a value, we need one other coordinate, and we do know the one other coordinate. It doesn't have to be the y-intercept. It can be any coordinate on the graph. But this is the y-intercept. We know that it's going to be 0, -4. So we are going to substitute that in. So we're going to get -4 equals a, 0 plus 2, 0 minus 6. Okay, and now tidying that up, -4 is equal to a, 2 times -6. So we have -4 equals -12a, and we're going to divide by -12 and divide by -12, and so a is equal to 1/3. Are we finished? No, because they said write the equation in the form y equals ax squared plus bx plus c. So let's do that. So I'm going to go back here. We know it's going to be y equals 1/3, x plus 2, x minus 6, and we're going to multiply out this delight. Okay, so I like to multiply the brackets first, and I'm sure you do too, because the fraction in there is not going to be fun immediately. So rather, let's do this. So we're going to get x squared. Yeah, we're going to get -6 plus 2, so it's -4x minus 12. And now I'm going to times the third in, because it's much easier to work with at this stage. So it's 1/3 x squared minus 4/3 x minus, and if I divide by that, it's going to be 4. And so now I have the equation of g, or if you like, g dashed x, or just y equals, because they said give it in that form. Right, so let's see what the next question says. Okay, I want to just write the equation down before I forget. I think it was y equals 1/3 x squared minus 4/3 x. And since I have a very short memory span, clearly, let's just check what I had written down there lastly. Yes, -4, just to make sure I don't give you the wrong details. Sorry, I went the wrong way. Oh, wait, too far. Here we go. -4. Okay. Now it says, write down the coordinates of the turning points of g. Now, that is the equation that we've got over there of g dashed x. In other words, the derivative. How do we find the turning points on any graph? We find the derivative equal to 0. So at this stage, I think it's a good idea to remind your examiner that you know what you're talking about. You know that this is what this is. And for stationary points or turning points, we want the derivative to equal 0. So we have 0 equals 1/3 x squared minus 4/3 x minus 4. Now notice they only asked for the x coordinates. They didn't ask for the coordinates. I'll explain why they did that in a moment. So first thing I'm going to do is I'm going to get rid of the fraction by timesing by 3. So I've got x squared minus 4x minus 12. And then I'm going to factorize that. X and x, 6 and 2, a minus and a plus. In fact, I'm being silly because I'm going to go back to the graph and show you what I could have done, which was very silly of me to actually work this out. Anyhow, it doesn't matter. It's good to show you. You get the same answer. So the x coordinates are 6 and -2. Let's just see what it was worth in the drawing. It was 2 marks. So what you could have done, and I think this for 2 marks, they probably expected you to do this. Let me just get back to the graph. I think this is the graph. Do you agree with me that this is where the derivative was 0? And that was where x was 6 and x was -2. So in actual fact, they didn't stipulate you must work this out algebraically. So there was absolutely nothing wrong with you having gone back to the graph and say, okay, where the derivative is 0, that's where I'm going to have my turning points. Okay, so that's quite nice, actually. Right, the last question, I think there's a last question here, 3.3, 3.4. Yes, I think there might even be another one. Write down the x-coordinate of the point of inflection of the graph of G. Now, how do we get a point of inflection? I'm sure you remember, we find it by finding the second derivative equal to 0. So let's go back to the previous page where we've got the first derivative. It's over there. Let me use another color pen. So now I want g double dashed x, which is going to be 2/3 x minus 4/3. And for a point of inflection, we know that the second derivative must be 0. So 0 is equal to 2/3 x minus 4/3. And clearly we don't feel like working with those fractions, so let's times by 3. So 0 is equal to 2x minus 4. So 4 is equal to 2x, which means x is equal to 2. So that's where it's going to happen. So let's go back to the question now. We know it will happen at x equals 2. Now, it also makes sense if you look at the graph we had originally. So let's go back to the first graph, and I'll show you what I'm talking about here. Okay, if we look at the graph, remember this was the graph of the derivative. If we wanted to find the turning point, we would have found the derivative of this graph, which would have been g double dashed x, and we would have put it equal to 0. So it's actually where the turning point is. So what they've done is tell you that that x value is 2. So the graph is making perfect sense with the working we're doing. And it depends on the mark allocation. If they're giving something 1 mark, they're expecting you to just read it off, 1 or 2 marks. When it's 4 marks, they expect you to do some working. So you just got to be careful around what it's asking. Right, let's go to the questions again and see if there's a 3.5. Yes, there is. Okay, it says explain why G has a local maximum at x equals minus 2. So let's just go back to how this graph looked. It looked like this. Minus 2, 6, and I'm asking you to explain why it has a maximum. Now remember, this is the graph of the derivative. So one way to do it is to draw a little table and say, right, we are looking, in fact, let's make it a double table because then it makes it easier to see what's going on. We're looking at the values minus 2 and the value, I need one more column here, the value of 6. We know that that's going to be 0. So we know the derivative is 0 there, and these are the x values. Now, if I look to the left of the minus 2, what are my values going to be for the g of x? Hopefully you're going to be able to tell me it's going to be positive. Here, between these two, the values are negative. And this side of 6, they're positive. So in terms of the graph, it's gone uphill, positive gradient, becomes 0, negative gradient, and then become positive. So the original curve would have had that shape. So this is G that I've just drawn using the derivative. Now, if we look over there, we can see if it's gone up, 0, and down, it's a local maximum. And likewise, this one over here would be a local minimum. So you could qualify now. You could say the gradient, G dashed x is greater than 0 if x is less than minus 2, and g dashed x is smaller than 0 if x is greater than minus 2 and less than 6. Therefore, a local maximum at x equals minus 2. But I think that little table would be a very nice way of showing them. And then you could just write in here max, min. Now, a very interesting question is, and it's just a little spin, we've got a minute, so I'm going to quickly flash it through because I think it's worth mentioning. If we have a random graph drawn for us, let's go back to the one we drew earlier. It looked like this. I think it went... anyhow, if it's not the same graph, it's not the end of the world. Say that. And that was my original curve f. And I say to you, please go and draw the derivative graph without working out anything, just using the graph that we've got there. What we would do is we'd start, first of all, with the fact wherever there's a turning point, it would be an x cut on the derivative. Okay, so that's easy enough. So we know it'll be 0 there and there. Now, what is the gradient doing here? It's going downhill, so it would have been negative, so it would be under the line. Over here, the gradient is positive, so it would be above the line. And now it's a negative gradient again, so it's under the line. And that would be the graph of the derivative of f. Now, that's a very nice little question, and if I was asking an exam paper, I would be tempted to ask that. So I think it's quite nice to know how to do that. Of course, I could give you the derivative like this one and ask you to draw back to the original as well.
Right,
Right,
nice
Aaron,
one. Thank you
leave
so
it
much,
to you.
Lee. It's time for us to take another
Yes,
break.
sure.
We need to relax after such, you know, but not that much, because learning, you know, it doesn't need you to exhaust your mind, but you just keep on training your mind, and relaxing also helps there and there. But otherwise, Mindsetters, we'll see you after the break. Welcome back, Mindsetters. Now on the competition, I see that a lot of people are entering, which is so good. Share and tag yourself. Remember, Mindsetters, this is a day competition, but we are going to stop the clock right before the last segment of the show. We'll stop the clock for this show, but otherwise, the prize, you're only going to see it, or you're only going to know about it on the last show of the day, which is from 4 to 5 o'clock. So you make sure that you tune in for that lesson. It's going to be Matt's Lit Show. So that's when we'll reveal the prize. But otherwise, I also want to acknowledge the Mindsetters that are on the page, such as Nsovo, Nonkululego, and Minentle. And actually, Minentle has a question for you.
Great, I like questions.
Mini says, what does rate of change actually mean?
With pleasure, I will explain that to you. I must just tell you that rate of change is what calculus is all about. In fact, Newton, who was one of the developers of it, was developing it for science. So what I'm going to do is I'm going to go to the bottom of this page, just take it really down, and then I'll go up again to the actual question. You know, rate of change is a gradient in actual fact. So if you look at gradient, it is the change in y over the change in x. In other words, if we're looking at a straight line drawn over here, when we look at the gradient, we take 2 points on the line and we say the change in y over the change in x. So we look at, if the formula goes x2 minus x1, and the formula over here, y2 minus y1. So that is a rate of change. Now, of course, that can be developed to anything that has a gradient. So if you do science, I don't know if you do, but I'm going to assume that maybe that's why you're asking. If you're looking at your equations of motion, and you're looking at your S formula, where you know that S is equal to ut plus a half at squared. The science teacher would have told you that when you're looking at this, you would look at the gradient and you would look at the change in displacement over the change in time, which is just another way of saying look at the gradient. And of course, if you take the derivative of this with respect to t, you're going to get u plus at, which of course all the good science people are shouting, that's u plus at. And of course, velocity is equal to the change in velocity, let me rephrase that. The acceleration is the change in velocity with respect to the change in time. In other words, the derivative of velocity. So if we take the derivative of velocity, use a constant, it falls away, and I'm just going to get a. I'm writing equal signs everywhere. Okay, let's just get rid of those. So yes, that's what's going to happen, and you can see it. So basically, a rate of change is the gradient of whatever you're looking at. And in actual fact, what we're going to work with now is a maximum minimum problem, which is another form of rate of change. And so you can see it in all sorts of aspects. It's very, very useful in real life. Let's go to the question, and I'll try and wherever I get a chance mention that again. Good question. Thanks for asking that. Right, now, these maximum minimum problems, the biggest problem with them is there are lots of words. So what I suggest you do is you make a point of very carefully reading through and underlining what is important to the question, because some of the stuff is just background information. You don't really need it. So let's look here. A rectangular box is constructed. Now that's important to know because that gives you formulas in such a way that the length of the base, now that looks like it's important, is 3 times as long as its width. That is important. The material used to construct the top and the bottom of the box costs 100 Rand. So they're saying, if I'm looking at my box, the bottom and the top are costing me 100 Rand per square meter. And the material used to construct the sides of the box is 50 Rand per square meter. It's important, but let's first see if we need it at this stage. The box must have a volume, now that sounds important, of 9 meters cubed. Let the width of the box be X meters. So they've drawn the picture for us, which is great. And the first question says, determine an expression for the height h of the box in terms of x? Well, we know that the length is 3 times the width, so the length must be 3x. We don't know anything about the height, but we do know about the volume of the box. Now remember, volume on a regular figure is always the area of the base times the perpendicular height. So if we're looking at this, the area of the base of this will be x times 3x times the height. And we know that that's 9. So 9 is equal to 3x squared times height. So if we want to get height, we could say height is equal to 9 over 3x squared. In other words, height is 3 over x squared. Have we answered the question? Yes, we certainly have. We now have h in terms of x. Right, let's go to the next question. I'm just going to remember that and put it on this next question. So we know that this is equal to 3 over x squared, and this one is 3x. And now they say, show that the cost to construct the box can be expressed as cost equals blah, blah, blah. Now, what's nice about this question is they've told you what it's got to be. So even if you try and you don't get to it, you can assume it and carry on going on the question, which is very nice to have that situation. And we do it deliberately as examiners because we know it's not fair to penalize you all the way through. Then we strictly have to mark through with whatever you give. So it's much easier to say show, and then you can use it. Right, so let's go to what we knew. They told me that the top and the bottom of the box cost 100 Rand per square meter. Now, do you agree with me that the bottom is over here? So if I wanted to put in a kind of thing, I could, but there would be a bottom here that would mirror the top of the box completely. Now, what do we know about the area of that little pink shaded thing? It would be the length times the width. So that would be easy enough to get. So the area of the base would equal x times 3x, which is 3x squared. However, the top and the bottom would be twice that, because the top and the bottom would be identical. That's why it's rectangular. Would give me that. And therefore, the cost of the top and bottom is going to be 6x squared times 100. So it's going to be 600x squared. All right, now we go to working out the sides. Now, with a rectangular box, we know that this side and this side will be identical, and this side will be identical. So we need to work out the area of the two sides and the area of the two front ones, front and back, actually. So if we look at this, let's highlight it in yellow. Let's start with this one. If I was going to find the area of this yellow thing, the area would equal 3x times the h, which is 3 over x squared, which means I would get 9 over x. Now, I know that the area of this front one, 9 over x, would be the same as the one at the back. So I know that the area of those, so let's go to this, so the area of the front and the back is going to be 2 lots of 9 over x. And the area, let's change color again, of the sides would be, and let's go back to that, in the drawing. The drawing is very useful. It helps you to focus in with what you need to know. Is going to be x times 3 over x squared, which is going to be 3 over x, and there are 2 of them, so 2 lots of 3 over x. 2 lots of 3 over x. So the cost is 50 Rand times these two areas, which are 18 over x plus 6 over x. Right, which is equal to 50 times 24 over x. The denominators are the same, so we can just add the numerators. and that times that is 1200. I can check on the calculator, but I don't think we need to. I think I'm right. So then the total cost is going to equal 1200 over x added to the one that we worked out in the very beginning, which is 600x squared. Let's check back and see if we got what they said we should have got. And I'm sure we did. Yes, there it is. Perfect. So what's nice is if I had gone wrong, it's worth 3 marks. If I see I'm a little bit off, I could carry on going with the question. If I've got time, come back to it, rather than getting stuck on it and staying on that question. So let's see what the next question asks me. Okay, the next one says, calculate the width of the box, that is the value of x, if the cost is to be a minimum. Now, I'll talk about it in a moment. Remember, the cost was 1200 over x plus 600 over x squared. Now, as soon as you see the word minimum or maximum, so as soon as you see the word min or max, the way to do it is to find the first derivative equal to 0, solve for your 2x's, or 1x or 3x's, or however many x's you get, and then check with the second derivative if these are maximums or minimums. So let's work this through and you'll see how it works. Now, if I look at this, the first derivative, I'd first have to tidy this up. I'd write it as 1200 x to the minus 1 plus 600 x squared. So the derivative would be bringing the minus 1 in front, reduced by 1, plus 1200 x. Right, so tidying it up, we're going to put it equal to 0, and we're going to tidy it up. So it's 1200 over x squared plus 1200 x. I can see that I can divide through by 1200 and make my life a lot easier. So 0 is equal to minus 1 over x squared plus x. Timesing through by x squared, I'm going to get minus 1 plus x cubed, which means x cubed is 1. And if that's the case, x is 1. Now, I need to check, is this a minimum or maximum? So remember what I told you. We go back to the first derivative, and we find the second derivative. So here we go, there it is. We want the second derivative. Doing that, we are going to get plus 2400 x to the minus 3 plus 1200. So in other words, tidying it up, I'm going to get 2400 over x cubed plus 1200. Now, we're going to take the value we got for x and put it in there. And if we do, we're going to get 2400 over 1 plus 1200, which is 3600, which is greater than 0, and therefore, is that a min or a max? Well, it's positive, so it's a minimum value. Now, so it turns out you only got one value. Well, I don't think they would have asked you the question if it couldn't work out. So you can be safe in saying it's a minimum, but just worth remembering, if the second derivative is positive, it's a minimum. If the second derivative is negative, it's a maximum. And just in case you get more than one answer, you might have to actually back that up. So they just wanted the value of x. So we can go back to our drawing here. We know that this is 1. They didn't ask me this, but I know that that would be 3. And they didn't ask me that, so it would be, I think, 1, no, it'll be 3. So that would have given you the volume of 9. You can see 3 times 1 times 3. So it works out perfectly. I always like to just check it like that, because I knew what the volume was in the beginning, so it's actually worth having a look and seeing. Okay, are we feeling all right? Are there any questions for us?
Here's one, like based on that. It's from Cool Kid. Cool Kid says, I've been checking the past exam papers, especially finals. Those questions of the maximum and the minimum aren't there. So can I exclude them?
I would never suggest that. In fact, this one came out of a past paper. Let's just go back and find out which one it came out of. This is Paper 1, yeah, there it is, 2013, that's February, March, that's the supplementary, question 11. So be careful, you know what happens, and I mean, I shouldn't share this with you, it's a very bad thing, why not? It's always good to know how things work. What happens with a thing, they'll see that a question's going really well, and the teachers are teaching it really well, and the pupils know it. They stop asking it for a while. Then they put it in again, and if it's a disaster, they keep on asking it until everything looks rosy again, then they'll drop it for a while. So what they try and do is they almost monitor that the teaching is happening to a good standard by testing. So perhaps for a while there had been no need to ask it. Now they've thrown it in again, and depending how everybody did in February, March, could decide whether it appears in your final here.
So that's a
don't
lesson,
leave
never
it
take
out.
anything for granted.
No. You know, I'd rather sleep the night before knowing that you've done everything you could do. I must say the negative of a question like this is the language, that sometimes it can get very hard, but they could simplify the language, make it very basic, that you don't have to fight your way through it. This was quite a hard one, with the cost thrown in and everything. So don't take a risk. It's never a good idea.
Never take any risk. Otherwise, I think it's time for us to take an ad break.
Super.
But as you're about to take that ad break, I just want to acknowledge the new mindsetters that have liked the page today. Welcome to the family. George Franz saying, wow, this is an interesting show, since I'm also new on the page. And Tabo says, Tabo Muleleki says, I didn't understand the graphs before, but now I understand them, all because of mindset. Thanks a lot, mindset. Thank you so much, Tabo, for also concentrating and learning more. Otherwise, mindsetters, like the page, be on the page, comment on the page, and we'll see you right after this. Welcome back, mindsetters. Now we are about to stop the clock. The clock is stopping right now on 53,742. So the last number is 2. So all the people that have tagged 2 and that have shared 2 on their statuses will get through our draw, and we'll announce the winner on the last show of the day from 4 o'clock up until 5 o'clock. So make sure that you tune in there and see if you are the winner. Again, the clock stops at 2. But now, Lee, was 2 your lucky number? You didn't have any lucky number.
I actually like 2 and 7 are my lucky 2.
Okay.
It's because they're nice prime numbers.
I would have chosen 2, you know. But otherwise, I have a question for you.
Good.
It's a question from Leanne. Leanne says, how do I change a graph that is not a function into a function?
Right, good question, Leanne. I must just say I'm so encouraged by how many of you are asking questions. That is so good. Because really, that's what really helps you, is when you ask the questions you want to know about.
Yes.
I just want to say that the only way we can change something into a function that is not a function is to restrict the domain. So perhaps I can just squeeze in one right at the bottom here. I'll try and just take it right down. If, say, for example, I'm looking at something like this, maybe. I could restrict it so that only the top half works or the bottom half works, and then it would make it a function. Because remember, the test for a function is being able to pull a vertical line through it and only have it cross once. So I would have to restrict it in some way. So if this was the inverse, I would probably say, and y is greater than or equal to 0. So that would take off this part. So I would know it was only the top part, which would make it a function. So that's the only way you can get it to, you can split it by using the domain or the range.
And whilst you're still there, Annalisa says, how do you restrict a graph to become a function?
It's exactly the same question again. So I'm trying to think if I can think of a better example of, just off the top of my head, I can't, because most of our graphs we work with are, again, it's the same thing. We would restrict it. So if we had a normal graph, I don't know, let's make it a circle. Okay, and say it was cutting at -2 and +2 and 2 and -2. Again, to make it a function, you'd have to make sure that it only has one intercept with a vertical line. So if I took that yellow top, I could be sure it was a function, or if I take that pink bottom, it could be a function. So the only way I could do it there was to tell them y again greater than or equal to 0, or y less than 0, or y less than or equal to 0. So anything like that, that you just make sure that the vertical line, when you go through it, goes like that. And then just a little bit of advice from me, you know, in the light of the conversation about the minimum and maximum question. Be very careful about second-guessing the examiner. Because like the question I'm going to do with you now was one that came up where they gave you the graph for the linear programming. But then, that doesn't mean they're going to do that again. They might do it again, in fact they could. Or, depending how the people answered it, they might ask something totally different. So just be careful and remember this year, your matric year is the last year they're going to ask linear programming. So I don't believe they're out to kill you. Any other questions over? Or shall I hit
No,
into
in the
this
meantime,
one? Okay, good. Let's go to this question. The reason we're doing it is it's unusual that they do this. They usually get you to draw it. They say a system of constraints is given below. Their boundary lines are represented graphically in the sketch below, and the constraints are. So they give you all the constraints. That's quite a nice way to ask linear programming, because you don't have to sift through the words to get the understanding, and they've given you the equation. But you must now go to the graph and decide which graph is which. That's not too bad. Let's show you why I say that. Okay, the first one said y lies between 0 and 50. So y would be a line that is vertical, 0 and 50, and I must just find where 50 is. Y 0, yeah, here it is, 0 and 50. Okay, I need to perhaps just put in some lines here. So this would be y equals 0, which is the x-axis, and the 51 is over here, y equals 50. Now, it's interesting because they say y lies between those two. So what I'm going to do is I'm going to show an arrow going down and an arrow going up from those two values. Now, basically, they're going to ask me to shade this because they didn't shade it. So the chances are that's what they're going to do. So I'm just preempting a question basically without even really looking what they're asking. The next one tells me x lies from 0 to 40. So, okay, going back to this equation, x equals 0 is the y-axis, and x equals 40 is my yellow line. And it's lying between these two, so I know it's inwards like this and inwards like this. So far there's a nice little box that is possible for my shading. All right, the next one says to me, 2x plus y is less than equal to 60. Now, my quick way of doing it is I cover over the 2x and I say y is 60. So I'm working with the orange or the green line. But if I let y equal 0, then x is going to be 30. And then that means I'm dealing with this line here. So in actual fact, I'm working with 2x. Oh, don't let it jump like that. Okay, sorry, it's 2x plus y less than equal to 60. Means that we are going to look at that, and to shade that, it's y less than, so it's underneath. So far we're looking like this. And now we go to this next one, which says, and now this is an interesting one, and I want to split this up and mention it. 35 less than equal to x plus y, and x plus y less than equal to 60. So this one is going to cut at 35, so we know it's the blue one. And remember what I said to you, we've got to get it into y form to see what is happening. So minus x plus 35 is less than equal to y. So y is greater than that line. So if we go back here, it's going to be greater than this. So we're above this line, the blue line. And then the last one is that x plus y is less than equal to 60, so it's the green line. Less than equal to is here. All right, so now they want me, what did they actually ask me to do? I didn't even look at that. I just looked at the drawing and got some sense going. Well, if I look at all the things, I'm in this box, I'm under the green, I'm under the orange, and I'm above the blue. So it looks to me like the only part that I'm interested in is this part here. Because it has to be under this orange line and under the green. Well, the whole orange line is under the green. So that's what I'm interested in over there, just that little bit. So it's quite deceptive. There are lots of things that haven't really affected anything. Let's go and look at the questions. First question says, shade the feasible region on the diagram. Well, we've done that, so we know we've got that right. Right, the next one says, oh, I went a bit too far, I think. I think they might be underneath. Yes, indicate which constraints have no influence on the feasible region. In other words, which graphs did we draw that really made no difference? So we go back to the graph and let's see. Well, I can see clearly that this green line had no influence. This line over here had no influence. This one did influence, that one did influence, and this one did not. So I would tell them that the x plus y less than equal to 60 had no influence, the y greater than 0, and the x smaller than 40. They did nothing to the graph at all. All right, so let's go back to the questions. I think that's those two. Let's go to the third one. The fourth one says, if P equals 4x plus y in the feasible region, determine the maximum value of P. Now, this is where we use our search line. So the first thing we would do is we would get this into y form. So we'd say y is equal to minus 4x plus P. And then we'd use the gradient of negative 4 to search the region. So we go back to our drawing again. Right, this is it. And we're now going to look at, if we have a negative 4, what the gradient will look like. So I'm going to pick this up and draw a line. Negative 4 means I must go 4 units down and 1 across. So in fact, let me just use some color first of all before I do that. Let's just use a normal pen. So if I use 1, 2, 3, 4 blocks, and I start from the 20, go down there and across there, and I draw my line in with that. And I won't win prizes for a nice draw, but I'm trying. Let's just straighten it a little bit. Yep, I think that looks good. It's good enough, anyhow, to explain. Now, if we are looking for, was it a minimum value or maximum value? This is the old age creeping in on me here. Let's just go to the next page and see. Oh, I always do this. Yeah, they went the maximum value. Sorry, so back we go. They want the maximum value, so it must be the last point of contact with the feasible region. So we pick it up, and I want to lift it and slide it, and because I want to do that, it's not being kind to me. I'm sure it'll do it now. Let's try again. No, it's not being nice to me, so let me just do it manually. If I slide this line, keeping it parallel, oh, there you go, it's doing it now. Okay, and there it is. It looks like it's at B. Oh gosh, my line just shot off into the middle distance. So let's bring it back. Okay, it's giving me a hard time, but the line should have ended up at B. And I'm now on black pens instead of red ones. So it would have happened here. And so the maximum happens at B. And B's coordinate was 5, 50. So that's important to know. Let's go back to the question. So we know that at 5, 50 we get our maximum. So they want to know what is the maximum value of P. Well, that's going to be easy. We're going to go to our equation. P is equal to 4 times 5 plus 50, which means we're going to get 70. Okay, I was a bit rushed in that question, but I think you've got the idea of it. Hopefully you've seen that, but just remember, if that went well, chances are you'll see something different. If it didn't go well, you might see something the same. So never just give up. Leave out things. Try not to do that as much as possible. Other subjects you can get away with, but not in maths.
Right.
Great.
No, thank you so much, Lee. We've come to the end of this session. Thank you so much.
It's been great being with you, and thank you for sending all your questions in.
All right, mindsetters, know that learning doesn't end here. Still practice and learn more with us. Remember, we're here to assist you on our Facebook page. We'll always be there for you. Otherwise, thank you so much for taking your time and learning more with us. The competition has stopped. We'll find out the winners on the last show at 4 o'clock. From us to you, we just want to say keep learning more because we love you. Peace.